In this video, I'm going to talk about basic terminology in electrical engineering. The basic terms are basically we're going to talk about charge, current, voltage, power, energy, resistance. There are a few more terms like capacitor, inductors. I'm not going to discuss them in this video. So first I'll talk about charge. Charge is nothing but it's a physical property of a matter. Okay, so if you look at a matter, every matter is made up with atoms. So if you look at an atom has a nucleus. So in the nucleus we have protons are positively charged. Positively charged. By the way, this is a simple form of representing positive and negative. Okay, this is negative, that's positive. So if you look at any nucleus has protons and neutrons inside the nucleus, and electrons are revolving around the nucleus in an orbit. So this is first orbit. This orbit can hold 2 electrons. Next orbit can hold 8 electrons, and third one 18 electrons. And the fourth one can hold up to 32 electrons. Okay, so these electrons, or that's a property of an electron, they are negatively charged, and protons inside the nucleus, they have positively charged. Now as I mentioned, two types of charges, positive and negative, and opposite charges attract each other, same charges repel each other. So charge we indicate with Q measured in coulomb. Coulomb is a person's last name, so make sure don't add s at the end. It is 5 coulomb, 10 coulomb, 100 coulomb, but not s, not 100 coulombs. That's wrong. It's 100 coulomb. Okay, that's about charge. Now the current is nothing but flow of electrons. When these electrons are moving, that is nothing but in one direction. Okay, electrons are always move, they never sit constantly, but if they're moving in one direction, so there is a displacement after some time. So if electron is here, so this is an electron. Usually when there is no energy or when there is no external force, this electron keep moving around that base. So the displacement after some time is going to be zero. It's not going to move anywhere. So this displacement is zero, so there is no current flow. So if current is moving, if the electrons are moving in one direction in a controlled motion manner, okay, so that's nothing but current. Say for example, here is a wire. Okay, you stand at one point. Okay, now these are the electrons, or charge, basically more number of electrons in each charge. So you stand at one point, how many number of electrons passed in 1 second? That's nothing but current. So I equal to Q over T. Okay, so I is measured in ampere. Ampere is nothing but, same thing, it's a person's last name, so do not add s. 1 ampere equal to 1 coulomb per second. 1 ampere equal to 1 coulomb per second. So there are two types of currents. One is AC current, another one is DC current. DC quantities we always indicate with capital letter I. AC quantities we always indicate with small letter with suffix t, I of t, AC current. Okay, so both AC and DC we always measure them in amperes, or ampere, sorry, not s, ampere. Now the third quantity is voltage. Voltage is nothing but work done to move the electrons from one place to another place. As I mentioned, the need current is nothing but controlled motion of an electron, so moving in one direction. So or controlled motion is the right definition than moving in one direction, because when it comes to AC current, alternating current is keep changing its direction. Okay. So yeah, when it comes to the voltage is nothing but work done to move the electrons from one place to another place. That is nothing but the voltage. Voltage is almost equivalent to EMF. There is a small difference between voltage and EMF, but for time being I'm going to take them equal, voltage and EMF. Now they both measured in volt. Volt is nothing but that's the unit of voltage. Okay, do not add s, that's also a person's last name. Now EMF is nothing but electromotive force. Both, I mean, voltage also, in also two types. One is AC voltage, another one is DC voltage. DC always capital letter V, small. AC is always small letter with suffix T. Both measured in volt. Okay, both of them measured in volt. The next quantity is power. Power is nothing but rate of doing work, how fast you can do that work. Rate of change of work is also nothing but rate of doing work. Okay, so simply rate of doing work. Here is the definition. Power we indicate with capital P. Both AC and DC, both quantities we indicate with capital P. P is nothing but voltage times current. P equal to VI measured in watt. That's also person's last name, so do not add S at the end. Okay, so the easiest way we use, okay, take a circle P and V and I. So if you want P, just close P with your finger. What do you have? P equal to V times I. If you want V, close V, V equal to P over I. And if you want I equal to P over V. That's about power. Energy, the next quantity. Energy is nothing but, energy is capacity to do work. So it's a capacity to do work. Energy is always measured in joule. Okay, another unit is, so as I said, energy usually indicate with E or U. I mean, depending upon some textbooks uses E, some textbooks uses U. U measured in joule, and E equal to P times time, right? So 1 joule equal to 1 watt second. That's the unit for, another unit for energy, 1 watt second. Okay, so if you remember, your energy bill, your electricity bill comes in kilowatt hour, right? Kilowatt hour. 1 kilowatt hour, can I write this as 1 kilowatt hour equal to 1 watt? Kilo is nothing but 1000 watt, sorry, 1000 watt times 1 hour is nothing but, times 1 hour is nothing but 3600 seconds. So basically 1 kilowatt hour is nothing but 36 times 10 to the power of 5, or you can say 3.6 mega watt second. Watt second is nothing but 1 joule. So basically 1 kilowatt hour equal to 3.6 mega, which is 10 to the power of 6 joule. Okay, that's the conversion for kilowatt hour to joule. The last quantity is resistance. Resistance is nothing but, it is opposition to the flow of current. Okay, it opposes the flow of current. Resistance, that's the symbol for resistor. The previous ones, none of them have a symbol. Most probably when it comes to the voltage, this is a symbol for voltage source, or sometimes you will indicate like this, that's a voltage source. When it comes to current source, that's a symbol for current source. Okay, you don't need to worry at this point, but this is the resistance symbol. R indicate with R measured in ohm. Okay, 5 ohm, 10 ohm, and ohm has a symbol here, omega symbol, that's the resistance. So first property of resistance, it opposes the flow of current. Second property is it converts electrical energy into heat or light. Okay, it converts electrical energy into heat or light. That's another property of resistor. Now I'm going to explain them, all these things, in a simple way. Now I'm going to explain this with a simple analogy here. So you are at school, you want to go to home. Okay, there are 3 different paths: path 1, path 2, and path 3. Okay, now what do you need? You need a vehicle, right? That vehicle could be your mom's car or your parents' car or a school bus. Okay, so when you are here, it's just like an electron, similar to the electron. Okay, when you're waiting for bus, you're going to stand still? No, you're going to roam around at that base, basically. So you are never going to be, I mean, not moving like a statue. You'll keep moving, but final displacement is almost zero. So that's the reason there is no current. Now, when you get onto this vehicle, okay, when you get onto this vehicle, it could be a school bus, or as you mentioned, your mom's car. Now, when this is moving, this is called current. Okay, what is carrying you? Bus, right? That bus is nothing but voltage. Okay, bus is nothing but voltage. Now, what is power? Power is nothing but how many vehicles are there. Power P equal to V times I. How many vehicles are there? How many passengers are there? That's nothing but power. And energy is nothing but how many vehicles are there, how many passengers are there, times how much time does it take to reach your destination. That's the energy. Okay. Now, what is resistance? Go ahead and guess. Pause the video and go ahead and guess. So here, the resistance could be a traffic light, which opposes the, flow of number of buses in that path or vehicles in that path. Okay, a traffic light is a resistance, or a speed bump is a resistance, or a cop is resistance. You see, if there is a cop in that line, most probably, I mean, if it is a 40 miles per hour road, we usually go 45 or 46, 47. Try to avoid that road if there is a cop, or we try to go slow. So it's minimizing number of vehicles passing through that path. That's nothing but resistance. Okay, I'll stop this video here. Okay, before stopping the video, which one is more dangerous, current or voltage? So here, so current is nothing but number of passengers, right? So how many electrons? Okay, passengers are, when the passenger is moving, that's nothing but current. So more passengers moving, more current is flowing. Okay, and vehicles are nothing but, it could be a size of the vehicle, like a bicycle has less voltage, or a 12-wheel truck has a more voltage. Okay, so which one is more dangerous, voltage or current? So is it a bicycle is dangerous, or a truck is dangerous? A bicycle with 12 people is more dangerous than a truck without any people, right? Because without any people, that means it's a standstill, it's not moving. Okay, so basically for electric shock, both voltage and current, both are responsible. Okay, I'll stop this video here. Thank you.